Good evening, everyone. So I guess we can start since it's getting late now. So yeah, today will be the sixth and last session of DSA Business Bootcamp, and we'll mostly be discussing a roadmap on how to continue with DSA after completing this bootcamp. So make sure if your friends have not joined it, just ask them to join. And Akshay sir, can we start now?
Yeah, let's start. Sorry if my voice is a little low today. I'm a little tired from work, so sharing my screen. So when we started this DSA boot camp, I had a lot of things planned for you guys. I basically put way too much into the syllabus, but then I started curating it class by class as we went on, and as the people, how you guys responded and understood, and based on your pace I curated it, and it seems like we kind of got the perfect output. So right now in DSA, you people are aware of C++ syntax and Java syntax, and also you are aware of most basic data structures and a few ways in which you can trace your programs, debug, and also formulate logic. So this is what we've done so far. So with this much, I can assuredly say that you people can go up to 2 or even 3 stars on CodeChef, which is not bad. It's actually really good, and it's gonna put something good on your resume. You will be given more opportunities because of this. But this is not enough. So far, the basic data structures, right? So this, you can go as deep as you want into it, and you'll master it completely, but you're not learning new things. So what you've learned so far is a really good starting step for you to get into DSA, but it's not enough. Um, so we have something called a fox and a hedgehog in technical terminologies. So a fox is basically a person who does not get too in depth into something, but the person tries out a various assortment of technologies. So the person might not just stick to making servers on Java. The person might even go to Python and JavaScript, and they are really keen on learning new things. They make their scope really wide, but the amount of knowledge they have in each of these is mediocre. It's enough to get work done, but they're not specialists. And the other kind is the hedgehog. So they focus on just one particular technology. Being a fox or being a hedgehog. Can I get some answers in the chat? Really quick. Fox or hedgehog?
Or
Did you guys not understand what I just said? So everyone is saying hedgehog. But contrary to that, it's actually better to be a fox. Because when you think about, okay, just give me a minute. I need to take this from work. Um, all right, I'll keep going on. All right. So I'll tell you guys. So say you become a Java expert and you really know a lot of Java. Your scope for work is just going to be limited to Java. Java has been here for a long time. It is still standing. It's going to be here for a while longer. But new technologies are coming. They are better than Java. But those technologies are not going to last as well. So it's always better for you guys to learn new things and understand why a new thing is coming in the first place. Say, for example, Java and JavaScript. So now, when you think about making a web application, JavaScript is much faster, and it also gives this benefit to the developer. So a developer who is making a JavaScript backend and a front end does not need to know a new language. It does not need to switch between Java and JavaScript and get the syntaxes confused. So it's easier for development. And JavaScript also has its own perks which Java may not offer. In some situations, Java may be better. So depending on the situation and what you're doing, many different technologies are going to be helpful. So same way, when you're doing some DSA problems, right? Yesterday, if you guys remember, we solved a problem where we had to find the two smallest numbers and then return the sum, right? So what we did initially, we sorted it like an array, and then we tried to find it, but it was giving us a TLE, time limit exceeded. So how did we solve it? Instead of solving it as an array, we took the concept of an array, but we went mathematical. We just used if conditions. We didn't sort it. We just handpicked the two smallest ones because we don't care about the hundreds of elements that are beyond the two smallest ones, right? So, in different situations, different approaches are really helpful. There is no one way to solve a problem. There may be 10 ways for you to solve the same problem. It's your job as a programmer to find the most efficient way. It should not take up too much memory. It should not take up too much CPU time. So for that, different data structures come in handy. Now there is something called expression evaluation. Do you guys know infix, postfix, and prefix expressions? So let's say 2 is plus 2 3 and 2 3 plus. So each of all three mean the same thing, but they are evaluated differently. So whenever you write an expression to your program, the way your computer internally executes it is different. It's going to be converted to a postfix or an infix, and then it's going to be evaluated. So how would you evaluate a postfix or a prefix expression? You can take it as an array and do all kinds of if conditions and stuff. You will be able to do it, but it's going to be a really lengthy problem. But what you can do is you can instead make a stack. Just uh, all right, I think that should be it somewhere. Okay, so whenever you are using a stack for this, right? So what you can basically do is you find a number 2, you push it onto the stack. You find a number 3, you push it onto the stack. You encounter a plus, you pop two numbers from the stack and you add it and you store the result. So you get 5, you push it back onto the stack. It's that easy if you use a stack. But if you have you know if you have something like an array for the same thing, you're going to go indexes a number, the next index I plus 1 is a number, and then you're going to say I plus 2, it is not a number, it is an operator. Then you have to go back to I plus 1 and I and then take them, and then you got to add them, and then you're going to store it in a new array. It gets really complicated, but a stack is designed exactly for this, right? Because only numbers are being pushed in and only two numbers are being taken out. It makes perfect sense to use a stack. Your code is going to be leaner, that means it's going to be small and neat and very readable, and it also makes development easier for you guys. So based on the problem, a different data structure or a different approach is going to vastly speed up your development and your result. So do you guys really remember what we did yesterday, that smallest one? I'm really glad that we got a TLE because we got to explore a different approach. So that really came in handy for explaining today's class. So I will be telling you guys what you have to know so that you can become a DSA expert, and these are actually going to help you for interviews. Um, I think the first technical round, mostly they're gonna ask you your logical questions so that they are sure that you are able to come up with solutions on the spot. So knowing these concepts are going, they are like it's going to be a really big asset for you guys. You can ace through any technical round. You can ace through any programming round. So these are not as easy as the ones that we went through, but because of the easy concepts that these next concepts are going to be really easy. Did I write down the question? All right. So you guys know basic syntax now, but you guys don't know the entire syntax. As you keep coding, you're going to understand more syntactical things, whether it be C++ or Java. So for this, keep coding, keep solving problems. Next is mathematical problems. So a lot of problems are mathematical in nature. For example, like when we had to find the two smallest numbers, instead of sorting the entire thing, we used our mathematical knowledge. What did we say? There exists a smallest number which is smaller than every other number. That is just a mathematical concept. A smaller number, it's a mathematical concept. So what is the second smallest number? It is larger than the smallest number, but it is less than everything else. So mathematical concepts. So maybe let's just go to code chef if we can. If you go to self-learning, I'm guessing these basic programming concepts are going to be mathematical in nature. The smallest possible whole number, weight balance, these are just mathematical operations. So you got to read the question carefully, perform those operations to the best of your ability. These can get a little tricky sometimes, but this you'll only learn with practice as well. So mathematical concepts, you won't get it automatically. You will have to go through a lot of questions for you to get that. So on that, the next one is arrays. We've already done arrays, but I do strongly encourage you guys to do more problems on sorting and searching basically. So this is what you will do most of the time, and I do encourage you guys do this. And as I explained here with our example for infix, prefix, and postfix expressions, see how a stack came into the picture. It was helpful. Same way for certain problems, queues are more adequate than arrays. So this also you have to go through problems for stacks and queues. We haven't really done any problems for stacks and queues, but I have taught you how to create a stack and a queue and use it. So you just have to move on to the application. So here what it means to have an application of a stack and queue is your implementation is going to remain the same. You're just going to have push, pop, NQ, DQ, same things. Logic is not going to change for the stack or the queue. But what you're doing using a stack or a queue, this is going to change. See, for our example for this infix and postfix expressions, our stack is the same. It can push, it can pop. But what we're doing with it, our logic is to push all numbers inside, and whenever we are finding an operator, we are taking two numbers and we're doing the operation and we're pushing back the result. This is your application. What you're going to do with the stack to solve some problem. So as you go on, you will be learning that. And recursion, we've touched on it. I've just taught you guys one simple problem. but the concept is same. What you have to learn in recursion is you must learn to find your own base case. You must learn to find your own recursive calls. So in our example, we took 5 factorial can be written as 5 into 4 factorial. Same way, you must be able to break down problems into sub problems. Don't worry, it's not really easy at first, but if you cannot solve a problem, Google the solution. There's no shame in Googling the solution, because if you do not know the answer and you then learn the answer, something new is going inside your head. Whenever you solve something that you already know, that concept is being reinforced. But whenever you don't know something and you learn it, you're learning something new. So both of these are a plus. You don't have to feel shame for not being able to solve anything. The number of times I've Googled solutions, even recently, uh, you know, everyone has to do it. So go through recursion. I'll say, at least do 10 to 15 problems on recursion. Understand the concept clearly. And this is actually written in order, these first 5 so far. This is going to really help you with how much ever we've done so far. The next bit, these 5 are things that we haven't touched, and these will be building on top of this actually. So, what is dynamic programming, divide and conquer, and greedy algorithm? These are just different programming philosophies, you could say. So, recursion is a little wasteful. So, whenever you write a recursive program, the time complexity is pretty large. It is 2 to the power n, if I'm not wrong. I'm not really sure. Let's find out. Yeah. So basically, it's gonna be how much is it? I don't want to go through all of this, and they just give me the final. So for each and every problem, it's gonna be different because the number of times you're doing recursive calls are, depending on the function. For example, if you're doing something like a merge sort, right? You will have to call that recursive function 2 times per call. Like if the first time I go into that function, I'll call it 2 times, and those 2 are going to in turn call it 2 more times. But for factorial, we were just calling it once. So depending on the problem, it's going to change, but a recursive function by itself is quite wasteful. It's going to take up a lot of time, and it's going to do useless calculations. So instead of doing those useless calculations, if you can store the results somewhere, right? Say for example, you're gonna do this 4 factorial 5 times. So instead of doing 4 factorial over and over, that means 4 factorial needs to call 3 factorial, 3 factorial needs to call 2 factorial, 2 calls 1, 1 calls 0. This is happening 5 times. So if 4 factorial needs what, 4 3 2 1 0, 5 calls, 5 into 5, you're doing 25 function calls for no reason. When you do 5 calls itself, you know what 4 factorial is. But since you're not storing that value anywhere, you're doing it 25 times. So if you store that somewhere, saying 4 factorial is so and so, you do not need to do that calculation 4 more times. You can just fetch it from the memory. So that is what dynamic programming basically is. You're gonna make a recursion better. You're not going to do useless calculation. You're going to do the calculation based on need. That is dynamic programming. So divide and conquer. This basically what it is uh, for example, you remember our 5 factorial. You made it 4 factorial, 3 factorial. You are dividing the problem into sub problems, and then you are doing small calculations instead of large ones. So divide a problem into sub problems, do smaller calculations, and then add everything. You're done. That is divide and conquer. So, and greedy algorithm is used to get the best result. So, um, say you have five operations that can be done in any sequence. So you don't know which sequence is going to give you the maximum result. So that is where you employ a greedy algorithm to get the maximum result, you know. So all these three will use some form of recursion in them. So once you go through recursion, you can solve these three. These three are quite important when it comes to interviews and solving problems without exceeding time limits. You know, yesterday if you saw, we got a TLE. For many problems, you get TLEs if you do not employ the right algorithm. And next is graphs and trees. We have not even touched it. So basically a graph is this. A graph is n number of nodes that have an association with some other nodes, you know. So basically you'll have problems like finding the shortest path from A to not A, let's say from C to E perhaps. So you can maybe wait, I think this should be a better example. So from 2 to 5, if you want to find the shortest path, it is 1, just 2 to 5. But you can also go from here to here, here, or you can also do here, 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 and here. So there are many paths. To find the shortest path, there is an algorithm. So to find closed loops and so many things are there. So I have not even touched graphs, so I don't really want to go too in depth. But this is basically what it is. It's just a node that has some link to other nodes, and you might need to traverse from one node to another, find shortest path, and problems like this. Basically, 3 to 4 algorithms. You don't need to worry too much. Once you learn those 3 to 4 types of problems, you will never need to worry again. Everything is going to be based on the same thing. So maximum you will do around 5 to 8 algorithms for both of these. And we have trees. So trees are also a type of data structure. In a tree, what you have is you have a root. Just think of a normal tree, how the root is at the bottom and branches go up. Reverse it, you got a tree in computer science. So this is the root node, and it has 2 branches. These 2 branches have other branches. So here you will basically have something like search. Like if you want to search for the value of 10, there are things like depth first search and breadth first search. Do you come down one thing entirely and then like this and then like this and search, or do you search 1 2 3 4 5 6 7 8 9 10 like this, depth or breadth? So there are different algorithms, but this is basically just for searching and sorting. You won't have to do much here. Like in graphs, what did you have to do? You had to find paths and cycles and things like that. But here you just have to do some searching and sorting. So these two data structures, I want you people to go through it. They look a little scary right now, not like arrays, because everything we've done so far is based on an array. But these also, you can the development can be done using an array. uh, as you go into it, you'll get to know. So go through trees and graphs and related algorithms. You don't even have to search to have, graphs, algorithms. Mhm. So what does it say? See, depth first search, breadth first search, and you can just go through this, and cycle detection, as I said, and minimum spanning tree, backtracking, shortest path. So you don't need to know all of these. Just go through some famous ones. Like Digixtra's shortest path is a famous one. Uh, Bellman-Ford is also something that's famous. Lloyd Warshall algorithm also, you could go through that. You don't have to go through all of these, but just know 2 to 3 handy from each one of these. So these are all concepts that you have to go through. Like see, maximum flow is a concept. Connectivity, shortest path, backtracking, minimum spanning tree, topological sorting, graph cycle, and the last one is uh, depth first search and breadth first search. These are just the topics. It looks scary. Don't have to go through everything. See, here you just need these two. You don't really, yeah, these three. The representation, breadth first search, depth first search. Done. And if you are feeling like you want to do more, do some applications and you're done. You really don't need to do all of them. And here, what do you need to do? Detect cycles in directed, undirected, um, okay, using colors, or you could go through this. But yeah, see here, go through this algorithm and this algorithm. I'll do something. I'll send you guys a document of things you have to go through later. So I'm just giving you guys a verbal overview for now. So even though it looks scary when you Google stuff, don't worry. Just go through the important ones. Just 2 algorithms are enough. Or and one more thing is always go for this. When you say, you know, you can write something like pros and cons. Here, so you will get to know. See, it does blind search, so it wastes a lot of time while processing. So you got to know one disadvantage. Okay, it cannot handle negative edges. It leads to acyclic graphs and most often cannot obtain the right shortest path. So this algorithm has 3 weaknesses. So you just need to know some other algorithm which can cover these three. So if you see, look at this Bellman-Ford. You come here and you just directly skip to the table. See here, non-negative values works correctly for directed and undirected. Here it also works correctly. Negative weights, it fails, works correctly for directed graphs only if it is negative. Negative cycles, it fails. It can detect negative cycles. So time complexity also is there. So you just Google stuff, compare which algorithm is used for what. So if this works for positive and this works for positive and negative, so you just learn this and this, you're done. So this is going to make learning simpler. You don't need to go through everything. Just the popular ones on Google are more than enough. So this is for trees and graphs. So that is what I've written here. Shortest path, traversal. You can also do search site. I'll just give you the link to this later. All of these problems are important actually. You can go through it. And the other one that we did not touch is linked list. So a linked list is basically an array, but its implementation is vastly different. You don't know the size of the linked list. The memory is allocated dynamically basically. The more see, when you create a linked list, right, it's gonna basically have nothing. When you add one item, it's gonna take memory just for one item. And when you have 2 items, it's going to take memory just for 2 items. 3, like this. So when you had to make an array, if you remember, you had to specify a size. Even if your array has only 5 items, if you specify 100, 95 locations are wasted. But when you think of a linked list, that is not the case. As and when required, new memory nodes are added. So since the way nodes are created itself is dynamic, you cannot use an index to traverse. So what you basically do is This one has a value. It has two parts. It has a pointer and it has the data value. Data value is the value at this node, and pointer basically points to the next location. So at the first location you have 5, and the next location's address it is pointing to. So you can use this address to go to the next location, fetch the value. So this is basically a linked list. So now a linked list, you can see a single linked list goes from here, it keeps going this side. So from here, right, we don't know the predecessor's address. You do not know this one's address from here. So from 20, you cannot go back to 15. So if you see a doubly linked list, 5 is saying the next one is 10, and 10 is saying the previous one is 5. And also it's saying the next is 15, from 15 previous is 10. So you can move both ways. And a circular list moves in just one direction, but from the last you can come back to the first. That is all this is. Once you spend around 15 minutes, you'll learn this very easily. So this is the linked list. Go through the implementation of a linked list. You need not go through applications for it, but know the implementation. And the last one I would urge you to learn are famous problems that are asked in interviews. So once you start learning things like dynamic programming, divide and conquer, greedy algorithm, um, wait, I'll show you. So I actually saw a really good website when I was learning it. So, yeah, educative.io. This is where I learned it. So you come here. This place has a really good explanation. It gives you examples, and what happens is I'll show you view all course details now. I don't think this was the one that I used. Let me just search. Mm, we don't need that one. Mm, let's see. This is also not the one. But if you see here, once you start exploring, right, minimum coin change in C++. The minimum coin change is a famous problem. So basically, say you want a value and you have and you have some coins. Say you want 100 rupees, and you have coins like no, not 100. Say you want 99 rupees, and you have 10 rupee coins, 5 rupee coins, 2 rupee coins, and 1 rupee coin. So what is the minimum number of coins that you need? So 9 10 rupee coins, 1 5 rupee coin, and 2 2 rupee coins. So what is that? 9 plus 1 is 10, and 2 more, it gives you uh, 12 coins. So how do you do it programmatically? So you can use dynamic programming in this scenario. So you can do it with recursion, but that's going to be really expensive. A dynamic programming solution is going to be better. So once you start learning those, right, you'll find problems like knapsack problem. So a knapsack problem basically, you can go through this. It's basically, imagine you have a bag. The bag can hold 20 kgs, and you are a shopkeeper. You are buying certain items to sell in a shop. Each item has a specific weight and a specific amount of profit it is going to give you. So you want to take the maximum profit. So that means you need to take, you're you're not supposed to take, say for example, um, one item gives you 100 rupees profit, but it take out of the 20 kg bag, it takes up 15 kgs. But there is something like an item can that is just 1 kg, but it gives you 20 rupee profit. So for 15 kgs, that 20 rupee item is going to give you how much profit? It's going to give you 300. So that is a better bet. So based on the number of items, the weight and profit, you want to bag the maximum profit. To do that, you're going to be using dynamic programming here. So that is basically the knapsack problem. Uh, so, there are greedy algorithms here if you want to see Huffman coding or, Prim's minimum spanning tree. These are all problems. If you just come here, look at this geeks for geeks. I didn't even have to search hard to find the problems. See, dynamic programming, the famous problems are like this: longest common subsequence, longest increasing subsequence, edit distance, coin change, the one that we saw before, matrix chain multiplication, so knapsack, and other problems. So here, if you see, you have backtracking, divide and conquer, a lot of algorithms and famous problems. I'll just save this to give this to you guys later. I'm just gonna put it at the bookmarks and you're done. So you know, so these problems are gonna be a game changer in interviews. I've attended quite a few of them. So what happens in technical rounds is they're gonna ask you saying, "Do you know n queens problem?" And if you know, well and good. If not, they're gonna explain the situation to you, and you're gonna have to solve it. So an n queen problem, I'll just tell you guys what it is. Mm, so you guys are all familiar with chess, right? So a queen can move in this direction. It can move up and down, and it can also move uh, diagonally. So how many queens can you place in a chess board of size? Here it is 4 into 4. Say it is 3 into 3. How many queens can you place? So if it's a 3 into 3 board, it will just be this much. This is a 3 into 3 board. You can place only one queen because this queen goes. It can attack here. It can attack here, and it can attack here as well. So you can place another queen here, or you can place it here. So when you place this empty position is also blocked. So you can place two queens in a chessboard of size 3 into 3. So to solve this, how you're going to do it, that is up to you. You can just use two for loops and do it, or you can use recursion to do it. So it is your duty to find such uh, famous problems that will be as in interviews, and learn different ways of solving it, and understand which way is better and why. So just if you're learning n queens problem, like n queens problem, recursion versus iteration. Um, so here you see, what does it say? Avoid duplicates in n queen. Iterative solutions, no recursion allowed. So this is a question that they asked. They didn't want recursion. So it's so you have to know how to do it with just for loops. This is the solution. So same way, what if they ask you saying, we don't want this, we want recursion. So it's always good for you guys to go a little bit deeper. One extra step is going to be a game changer in interviews. Because once you say I don't know, what are they gonna think? They're gonna think, okay, this person did not really do his research, did not really try to find out why there are two solutions and why one is better than the other. So uh, that's it for my roadmap. So these five are just building on what I taught you. So I mean, it's getting better at what I taught you, and these five are advanced versions of this basically. So graph, tree, and linked list is just a different data type, but you're gonna use an array to create them. You're gonna use 2D arrays actually, uh, or there are actually different ways for you to do it. You'll learn as you do it, but you're basically gonna use an array most of the time, or you could also use something like a linked list. Uh, so these three data types are a little more advanced. Don't panic, go through it. And the other parts are just applications of these three, just problems based on these. And the last one is these algorithms. Actually, don't just stick to these. Go through, where was the site? This isn't the one. Okay, I'll send you guys the site. There were a few algorithms there, right? Go through those algorithms and famous problems. You are done. You will be able to get, packages of up to 10, 15, or even 20 LPA just by, going through proper DSA. Because as you move into a company, right, I'll tell you guys, your company is going to have different requirements. So I'll tell you guys my experience. In my interview, all they asked me for was proper aptitude and DSA, along with a few object oriented concepts and a few syntactical things, nothing much. Because if you join an MNC, what happens is based on their demand, they're going to give you training. So I am a full stack developer. So I work on projects that are relevant to me. So a person could also be put into something like GCP. So that person is only gonna work relevant to that. So he doesn't need my training. I don't need his training. You're gonna get training based on the need. Give me a second. Okay, this is for me. Signed it to me. Give me a minute. Let me just go through this. Null point execution. Okay. Yeah. So relevant to my background, I'll be getting training. But DSA is something that goes into every single aspect. Even now when I'm working on my project, I may need to rearrange data or form some kind of a logical map. So I will be using DSA. So whenever you're applying for big companies like Google or Microsoft or Facebook, what happens is they will basically test your DSA, because that DSA shows how good of a knowledge you have on your basics. Everything else you can learn. Like for example, if you want to learn Angular or React or Vue, it hardly takes 2 weeks. It hardly takes 2 weeks to learn. So any framework you want to learn, it hardly takes 2 weeks. If you know Java, C++, you can learn it in a week. If you know C++, Java, you can learn it in a week. Python, everything you can learn, but DSA is where it all lies. It's how you understand data. It's how you can come up with solutions to problems. It's not something language specific. So this is your roadmap. I'll be sending you guys a doc around tomorrow. So yeah, that's it from me. Any doubts regarding what I just said? I can take them up right now. Just drop the doubts in the chat box. No, you will not be asked to solve in a specific language. Your interviewer is going to be really, they won't really create a very bad environment for you. They're going to ask you, what languages are you familiar with? And they're going to ask you to solve in that language only. You don't really have to know more than one language to get selected. It's always good for you to know a proper framework, but it's up to you, whatever language you want to choose. Python is good, but one thing is, I would suggest not to go for array problems with Python, because Python basically uses lists. So when you go use a list, what happens is it does not require you to have a specific data type. You can have one, you can have 1.5, you can have Apple all in the same list. So that kind of breaks the concept of an array, right? An array should have the same type of data. You can on your own make an array in Python, but it really doesn't. You're just going to be using a list. So try to use same thing if you want to use JavaScript. So if you want to use JavaScript, an array in JavaScript is basically just map. So it's not really great to solve DSA and JavaScript because it makes it too easy. You don't have to use your brain that much. So go for C++ or Java for DSA. That is really, and I would really suggest C++ because it's faster. Full stack development, I would really suggest you guys to go for JavaScript based frameworks. Now, Java has, Java was really getting tiresome and really old. Say for my project, right? I'm using a Java backend over there. The code is ancient. It is like 10, 15 years old. It's so horrible. So now what they're doing for Java backend is they're using something called Spring Boot. It is good in its own ways, but I still prefer JavaScript. So, when you go for JavaScript, it's good if you know MongoDB and PostgreSQL. So these two, for database, one is NoSQL and one is SQL. So, and for your server side framework, go for Express.js, and you just need to know some basics on Node, not too much. And then when it comes to front end, that's totally up to you guys. Now I know Angular, React, and Vue. That's PHP is not really. It used to be good, but no one really uses it now. If you want to learn PHP, go for Laravel. It's a framework. You don't just learn PHP by itself. Learn PHP and go for a framework. Same way, people who know JavaScript can't just say, I know JavaScript, I'm a developer. You need to know frameworks because a framework is going to cut your development time by half. So for front end, as I was saying, I know React, Vue, and Angular. You can start off with just one. After you learn one, other two are quite easy. But right now, React is really popular in the market. It's very popular, but at the same time, the learning curve is way too high. Vue is really good and it's catching speed, but it's not really there in the market yet. Angular is very easy to learn. It's very well structured, but you need to learn one extra thing, TypeScript. It takes half a day to learn TypeScript if you know JavaScript, but um, so it totally comes on you. React is super popular, easy to get a job. Angular is really good, and you can get a job, but if React gives you 100% job market, Angular is going to give you say 80. Maybe you'll find 20% less jobs, but there are jobs, good paying jobs, and it's always good to move on to the new and better one, right? So learning Vue is going to secure your future. Like yeah, backend is Node.js, that is a runtime. You can go with something like Express for the server side framework. There are more like Goa.js and other things, but Express is the most popular, and I don't think it's gonna change for a few years. So go for Express. Even if it does change, it's gonna be similar to Express, the new frameworks. And it is really good if you guys can go for if you are interested in development. That is, half the people nowadays are running behind data science. I don't really understand why, because it's really it'll get a long, it'll become a long discussion, but it is more likely that you'll do development than data science at your company. as a bachelor degree holder. That's what I'm going to say. So if you're going for, if you want to be a developer, learn something good in JavaScript. Or if you want to go for Java, go for Spring Boot. All right, any more questions?
So I guess since there are no more questions, we can wrap up. Okay, there is a question.
Um, I mean, that's, yeah, I don't know if you're saying Android development is easy or if you're asking me, but that's totally up to you. So, Android development is basically just front end again. Instead of learning, say, your Angular or something, you're gonna learn something like Flutter. So everyone is moving towards REST and GraphQL. So your front end and back end are basically separate now. Your front end is basically just displaying data, which it is asynchronously fetching from the back end. So even if you want to go for Android development, you just need to learn one extra thing. Like as I said, from Angular, how you're going to React or Vue, you just need to know Android front end. That is plenty. You don't really have to go too deep into anything.
Alright, so in case anyone has any more questions, feel free to reach out to us on our socials. We will be happy to answer you. And thank you so much, everyone, for joining all the 6 sessions and making this bootcamp successful. We will be having doubt sessions on demand. If there are any doubts, we'll help you out. But if not, then there won't be any more sessions. Uh, yeah, full stack. Kancha will come to that. Like we have 2 programs coming up. We have ML study jams coming up and web dev program. So yeah, when that happens, we'll definitely be inviting Akshay sir again to elaborate more on that. For now, a link was shared to a document that contains all the recordings and assignment details. So make sure everyone, please do finish your assignments by 29th of March. And on 30th, we'll be having a contest. And whoever performs the best in that contest will get a prize. So make sure you practice all the things that we taught until so far. And yeah, that's it. Any questions, anyone? Yeah, contest will be on 30th. Also, do join our Discord so you can ask doubts. Timings will be mostly we'll share it with you, but most probably in
I
the
mean,
evening.
wait for the notification, maybe, instead of trying to get all the information after the setup is done, they might share the time. Sharanya, yeah, sorry, don't mean to interrupt you.
Yeah, yeah, no problem. Discord link has been shared. Make sure you join it if you want to clear your doubts regarding DSA, get notifications about the DSA contest, and also notifications about the upcoming ML study jam and web dev study jam. So yeah, because like these are 2 Google powered programs where you'll get to learn machine learning concepts and web development concepts. So yeah, that's it from our side. Um, Thank you for joining everyone. See you all in the contest.